Good afternoon, student. As we are studying chapter thermodynamics, so today we have the topic bond dissociation enthalpy as we have studied Hess's law. Now the topic undergoes Hess's law is bond dissociation enthalpy, which is very important for further classes, especially in 12th and in BSc. In higher classes you will study in detail bond dissociation enthalpy in competitive exam also. So what is bond dissociation enthalpy? Firstly, we are going to define the term bond dissociation enthalpy. Okay, so the amount of energy is needed to break the bonds into atoms. So here is bonded. Here is the bonds break into the atoms. So this is called bond dissociation enthalpy. Okay, the energy required to break the bond into atom is called the bond dissociation enthalpy. Now bond dissociation enthalpy can be discussed for diatomic and polyatomic molecules. So it can be discussed both for diatomic and polyatomic molecule. So now for the first time is the diatomic molecule. So in diatomic molecule, the bond dissociation enthalpy is the same as the enthalpy of atomization okay, atomization denoted by H, del atomization H. Okay, so it may be defined as the amount of energy required to break 1 mole of a particular type between two atoms in the gaseous state of substance. Okay, so example, I am repeating here the definition of a diatomic molecules: amount of energy required to break 1 mole of particular type between two atoms in the gaseous state of the substance. जैसे for example hydrogen, which is in gaseous form, it has been broken like this. So 2H. Now the atomization of enthalpy would be negative. So we have 443 333 kilojoule mole inverse. In oxygen molecule, we have oxygen molecule in the gaseous form, so conversion in gaseous. So here the atomization of enthalpy will be 498 kilojoule per mole. Okay, so bond enthalpy is, if we compare both cases with each other, bond enthalpy of oxygen is expected to be less than that of the hydrogen, because the size because the size of hydrogen atom is smaller. Okay, now next reason, but it is a more, since a multiple bond has to be cleaved in oxygen molecule. Oxygen has multiple bond, whereas hydrogen has single. Okay, so oxygen, having double bond structure, and hydrogen has single bond with each other. Now for the polyatomic molecule. Polyatomic molecule. Firstly, need to be defined the average of the bond dissociation. The average of the bond dissociation enthalpy of the bond of the bonds of the same type in a gaseous substance, in a gaseous substance. Okay, we have an example. Water has, hydrogen single bond, oxygen single bond, hydrogen. So there are two oxygen and hydrogen bond. The bond dissociation energies bond dissociation energies of the two hydrogen and oxygen bonds will be hydrogen single bond, oxygen single bond, hydrogen convert into oxygen single bond, hydrogen and hydrogen. Okay, in which the association enthalpy will be positive 498 or 98 kilojoule. In the second case, oxygen and hydrogen deassociates in hydrogen and oxygen. So we would have the enthalpy is positive 428.5 kilojoule. So bond enthalpy of oxygen and single bond, according to our definition, the average of the bond dissociation enthalpy will be the sum of both dissociation 498 plus 428.5 upon 2. So you can calculate the further bond dissociation enthalpy. Okay, so this is the bond dissociation enthalpy for the polyatomic molecules. Now the calculation of enthalpy of the reaction. Calculation of enthalpy of reaction. Okay, the enthalpy of reaction, so the difference between in the bond energies or enthalpies of the reactants and products participating in the reaction. Okay, product and reactants both participate in the reaction. So enthalpy of reaction is denoted as del RH equal to bond energies of reactants minus bond energy of products. Okay, now based on this formula we will solve the example. Okay, so here is the question: calculate the enthalpy change for the reaction hydrogen plus chlorine convert into HCl. So given the bond enthalpy or energies of hydrogen and chlorine and hydrogen and single bond chlorines bonds are, so the data we have given 433, 244 and 431 kilojoule per mole. So the solution is ready. How can we solve such type of a questions? Firstly, we need to write the chemical equation which have been given to us. So the chemical equation for the reaction, we have hydrogen plus chlorine equal to 2HCl. Okay, so enthalpy of the reaction is equal to del RH equal to bond enthalpy of a reactant minus bond enthalpy of product. Okay, so according to our question, bond enthalpy of, firstly we have hydrogen, single bond hydrogen, plus bond enthalpy of chlorine, single bond chlorine, minus product bond enthalpy of 2HCl, in which we write 2 into hydrogen single bond chlorine. Okay, now the data is given to us: 433 of hydrogen single bond hydrogen, plus, and chlorine we have 244, minus, in product side we have 431. So after the calculation, into 2, we have in twice form 2 moles of HCl. So we will get minus 185 kilojoule after calculation. So the question will be solved like this. Okay, now the next topic is entropy changes in the phase transformation. So we have the topic is entropy changes in phase transformation. Entropy changes in phase transformations. So this is the new topic. We are studying thermodynamics chapter, which is so lengthy, and we have so many topics in this chapter, which is very crucial for the competitive exams. So entropy of the phase transformation. Okay, the change of substances, the change of substances from one state to other is called phase transformation. Okay, these changes take place in definite temperature, okay. So entropy of the fusion, change in entropy change in entropy when when 1 mole of solid 1 mole of solid at its melting point at its melting point changes to the vapor states changes to vapor state at the same temperature. So entropy of the fusion is defined as the change in the entropy when 1 mole of a solid at its melting point changes into vapor in liquid state at the same temperature. Okay, having some mistakes. So how can we express in mathematical? So mathematically, entropy denoted by S for the fusion, okay, is equal to entropy in liquid, okay, entropy minus solid, so equal to infusion upon temperature of a fusion is equal to delta fusion H upon Tf. So this is the entropy of a fusion. Now the entropy of vaporization. Entropy of vaporization entropy of vaporization. The change in entropy when 1 mole of liquid at its boiling point change in vapor state at same temperature. Okay, at same temperature. Having same temperature. Okay, mathematically how can we express the term for the vaporization? Entropy of vaporization is equal to entropy for the vapor minus entropy of liquid, okay, is equal to del H vaporization upon temperature at the boiling. Final equation del vapor of enthalpy is temperature of boiling. The next is the entropy of sublimation. Okay, the entropy of sublimation. So the change in energy or entropy when 1 mole of solid at a temperature below its melting point changes to the vapor state at the same temperature is known as entropy of sublimation. So entropy of sublimation is equal to vapor minus entropy of a solid is equal to del H for the sublimation upon temperature of sublimation below melting point is equal to sublimation H upon temperature for the sublimation. That's the final equation. Okay. Now question based on these terms. Problem. How can we solve the problem basis on this topic? So at 0 degrees Celsius, as 0 degrees Celsius, ice and water H2O are in equilibrium, and enthalpy changes, okay, for the process H2O reversible in H2O in liquid. This is solid to liquid. Okay, is 6.0 kilojoule per mole. Now calculate the entropy change for the conversion of ice into liquid water. Okay, this is the problem. Now how can we solve? Solution here. Firstly, the chemical equation H2O solid to liquid, so this is fusion. Okay, so fusion, fusion is equal to 6.00 kilojoule per mole, the value is given also, is equal to 6000 joule per mole. Okay, kilojoule has been converted into only joule. So fusion temperature is 0 degrees Celsius. So 0 plus 273 Kelvin. So we have 273 Kelvin at absolute. So del fusion entropy is equal to fusion H upon TF. Okay. So from this given formula we can calculate 6.00 upon 273. Here is kilojoule, or you can convert into joule. So we have 6000 upon 273 Kelvin. After the calculation, so we got 21.98 joule kilo inverse and mole inverse. Okay, so we can solve such type of problems like this. So this is all for the today's. I repeat, we had two topics of today's class. First, that was the first topic of today's class. It was the bond dissociation enthalpy.